In this video, I'm going to be talking about some of the basic definitions associated with the concentration of a solution. So the words we're going to be defining here today are saturated, unsaturated, and supersaturated. A solution is considered to be saturated if it's holding as much of the solute as it can without the solute coming back out of solution. So for example, if here's our water and we take some salt crystals and we put them in, and then they break up and they float around, at some point there's going to be so many sodium chlorides that they're going to start to recollect here and form a crystal of salt on the bottom. Saturated means the most dissolved ions that you can have without the formation of the crystal. So in a sense, this is the highest concentration that's sustainable in a solution. Unsaturated means any concentration below that amount, or when the solvent is holding less solute than it's able to. So here we're going to have less of these dissolved molecules. There's no crystal formation. And here we just have a really good solution where all the solute is well dissolved, and we could even add more solute and it wouldn't affect the overall solution. So I think those are sort of straightforward. The funny one is supersaturated. Supersaturated happens when the solvent contains more solute than it should be able to hold, or when there's more dissolved particles than should be able to be in the solution. So again, here we could imagine if we said that 2 was saturated, here we have a higher concentration than the saturation point. And what should happen here is that solute should begin to crystallize. Or come out of solution. This isn't always as easy or as quick as it might sound or what might make sense to you. Because these ions are all dissolved and they're floating about in random directions within this liquid, liquids can actually stay in a supersaturated state for quite some period of time. They might, depending on the nature of the crystal, require a seed crystal, essentially a material where the crystal can start growing from. To get the crystallization process to happen a little bit more quickly or to get it started. Some solutions can stay in a supersaturated state for extended periods of time if they don't have any seed, if they don't have any starting point for them to start to build with. Also, sometimes the crystallization process can be brought on but with physically hitting the solution or some sort of mechanical disturbance. That can cause the solute to all be in a local area for a brief period of time, and instead of putting in a seed crystal, form a small seed crystal, and as a result cause the crystallization process to happen. But this is strange. If this solvent should only be able to hold a certain amount of solute, how did we get supersaturated in the first place? There's different ways to do this, but the simplest way to get supersaturated is to use temperature. Most solvents can hold more solution at higher temperatures. I should say most liquid solvents. This actually goes the opposite way for gases, but we'll talk about the solubility of gases later. Most liquid solvents can hold more solid solute at higher temperatures. That's what I mean. So if I'm imagining, for example, salt and water, to get more salt dissolving in that water, I can simply raise the temperature of the water to get it up, to get the solubility up a little bit higher. So what we can imagine doing here then is we can imagine taking our liquid and heating it. Here's my little fire. This is going to be a fire. Heating it. Get the temperature up. Then we can dump in a lot of solute, and more of it will dissolve than otherwise would have. And then if we get rid of our fire, we take it away from the heat and we let the temperature come back down. So we raise the temperature, add lots of solute, more dissolves than usual due to increased heat. Then we let the temperature decrease. The solution is now supersaturated. Even that, when you look at that, you think to yourself, well, shouldn't it just come right out? Shouldn't it just crystallize and then we're back into the supersaturated situation? But as I said with the seed crystal, it might take a little bit of time. And if it takes a little bit of time to form the initial crystal, or if it requires an initial crystal to be added, some solutions can stay in their supersaturated states for extended periods of time. So, saturated, the most solute you can put in. Unsaturated, less than the most solute that you can put in. Supersaturated, above the amount of solute that should be able to fit into the material. This can be done simply by raising the temperature, raising the amount that can go in, and then letting the temperature come back down, and then you're into that supersaturated state. So that's saturated, supersaturated, and unsaturated.